Hello viewers, in today's session we are going to discuss a very important concept in application of derivatives, that is the concept of critical points, right? So we have already discussed the concept of turning points, stationary points, critical points and point of inflection in our earlier videos, and here just for the sake of revision, we are going to discuss the concept of critical points once again in this lecture, and here we'll see how we can find out the critical points of the functions, right? So let us start. So the concept of critical points plays an important role in studying the behavior of functions, and let us first take the definition of critical points, right? A critical point of a continuous function f is a point at which the derivative of the function f, which is denoted by f prime, is either 0 or not defined, right? So a critical point of a function f is a point at which the derivative is either 0 or it is undefined, right? So let us see with the help of some examples how we can utilize this definition, and we can find out the critical points of certain functions. So now to begin with, let us first consider these three functions, right? So here we are taking the mod function. In the first case, we have the function mod of x, right? And we know that the derivative of mod of x, it does not exist at x is equal to 0, right? So it implies that mod of x is not differentiable at x is equal to 0, right? So by the definition of critical point of a function, if the derivative is not defined at some point, then that point is the critical point for that function. So for this function f of x is equal to mod x is equal to 0 is our critical point, because at x is equal to 0, this function mod of x is not differentiable. So now consider the second problem. So here we have the function f of x is equal to mod of 2x minus 5, right? And we know that if we have a function, say mod of ax plus b, then this function is not differentiable at the point where ax plus b is equal to 0, right? That is at x is equal to minus b over a. This point is the critical point for this function, right? So in this case, we have a mod of 2x minus 5. So when we take 2x minus 5 is equal to 0, we get 2x is equal to 5, that is x is equal to 5 over 2, right? So at this point, this function f of x is not differentiable. It implies that the derivative of this function, it doesn't exist at x is equal to 5 by 2. So the critical point of this function is x is equal to 5 by 2. Now let us consider the third function. So here we have the combination of two mod functions, that is sum of two mod functions. So the first one, that is mod of 2x minus 1, this function is not differentiable at 2x minus 1 is equal to 0. It means x is equal to half, right? And similarly, this function mod of x plus 2, this function is not defined at the point where x plus 2 is equal to 0. So x is equal to minus 2, right? So this function f of x has the critical point half and minus 2. It means f of x has two critical points, that is minus 2 and half, where the derivative, it is not defined. Now let us consider this function, that is f of x is equal to square root of 2x minus 3. So here we have a square root function. So let us find out the derivative of this function, that is f prime of x. So the derivative of square root of 2x minus 3 is 1 over 2 times square root of 2x minus 3, and then by chain rule the derivative of 2x minus 3 is simply 2. So here 2 and 2 get cancelled, so we are left with 1 over square root of 2x minus 3, right? And from this expression we can see that the derivative, that is f prime of x, it does not exist at the points where 2x minus 3 is equal to 0, right? So we have x is equal to 3 over 2, right? And moreover, this derivative also, it doesn't exist when 2x minus 3 is less than 0. So when 2x minus 3 is less than 0, then we have a negative number inside the square root sign, and we do not have the derivative in the set of real numbers, right? So for 2x minus 3 less than 0, the derivative, it is not defined, right? So we have 2x less than 3, right? So we have x less than 3 by 2, right? So if we see the real number line, so here we have minus infinity, here we have plus infinity, and here we have x is equal to 3 over 2. So now if we look at this real number line, then we can see that for x is equal to 3 by 2, the derivative is not defined. And for x less than 3 by 2, it means for all these numbers, right, which falls in this region, the derivative is not defined, right? So we can say that this function f of x has the critical point 3 by 2 along with all those numbers which lies in this region, that is the shaded region, right? So we can say that the critical points of this function are in the interval that is from minus infinity to 3 by 2, right? So this function f of x has critical points that falls in this interval from minus infinity to 3 by 2, and here we have the closed interval, right? It means 3 by 2 is also included. Now consider this function f of x is equal to log of x square plus 1, right? So to get the critical points of this function, let us differentiate it. So we have f prime of x is equal to the derivative of log of x square plus 1. So this is 1 over x square plus 1, and by chain rule the derivative of x square plus 1 is simply 2x, right? So we have 2x over x square plus 1, right? So now if we put f prime of x is equal to 0, then we get this equation, that is 2x over x square plus 1 is equal to 0, right? So see, we have already seen that the critical point of a function are the points where the derivative is 0 or not defined, right? So see, the denominator is defined for all values of x, right? So the denominator is defined for all values of real numbers, that is x belonging to the set of real numbers, because here we have a square term, that is x square, right? So x square plus 1 is defined for all real numbers. So 2x over x square plus 1 is equal to 0. It gives us 2x is equal to 0. So we have x is equal to 0, right? So for x is equal to 0, the derivative of this function is equal to 0. So therefore, the critical point of this function is x is equal to 0. So this function has only one critical point, that is x is equal to 0. Now let us consider this function f of x is equal to e raised to minus x square. So let us differentiate it. So f prime of x is d by dx of e raised to minus x square. So the derivative of e raised to minus x square with respect to x is e raised to minus x square, and then by chain rule the derivative of minus x square. So now we can write e raised to minus x square. Derivative of minus x square is minus 2x. So we have minus 2x e raised to minus x square, right? So we can also write it as minus 2x over e raised to x square. So now to get the critical points of this function, we'll take f prime of x is equal to 0. So we have minus 2x over e raised to x square is equal to 0, right? Now see, here in the denominator we have the exponential function, and the exponential function is never equal to 0, right? And it is always a positive quantity, right? So here what we will get minus 2x is equal to 0. So we have x is equal to 0. So x is equal to 0 is the point, that is the critical point of this function f of x, because x is equal to 0 is the only point which makes the derivative equal to 0, because this term, that is e raised to x square, is never equal to 0, or this is always a positive quantity. Now let us consider this function f of x is equal to cos 4x, right? And we have to find the critical points for this function. So let us differentiate it. So f prime of x is the derivative of cos 4x, and the derivative is minus 4 sine 4x, right? Now to get the critical points of this function, we'll equate the derivative equal to 0. So now we have minus 4 sine 4x is equal to 0. So we have sine 4x is equal to 0, right? Now this is a trigonometric equation, and we know from the theory of trigonometric equations, that is sine theta is equal to 0. It implies theta is equal to n pi, where n belongs to the set of integers, right? So here our theta is 4x. So we have 4x is equal to n pi, where n is the n belongs to the set of integers, right? So x is equal to n pi over 4, right? So this function f of x is equal to cos 4x has these critical points where n belongs to the set of integers, that is n is equal to 0, plus minus 1, plus minus 2, plus minus 3, and so on, right? So we can conclude that this function f of x has an infinite number of critical points where the derivative of this function is equal to 0, right? So the values of x, which is equal to n pi by 4, it makes the derivative is equal to 0.